Hi, this is Mr. Tipton, and today we are back with Are Figures Similar? We've done our ratios proportional, but now we're looking at figures and are they similar? Figures are similar when two things are true. The first thing is when the corresponding sides are proportional, and the second thing is when the corresponding angles are congruent. Figures are similar when the corresponding sides are proportional and the corresponding angles are congruent. Both of these things have to be true, or else the figures are not similar. We're going to spend a little bit of time talking about corresponding sides and corresponding angles and making sure that we understand what this means. Pause it if you need to. Move on when you're ready. First, let's talk about corresponding sides. We're being asked if the two triangles are similar. Are they similar? We've got two triangles, a bigger one and a smaller one, but we want to know if they are similar. They're similar if they have the same shape, proportionally. Here you can see I've got the 9 and the 3 written in blue. 9 and 3 represent corresponding sides because they're both on the left side of the triangle. The bottoms of the triangle are written in green, and the diagonal line, the hypotenuse of these triangles, is written in red. Okay, the matching colors are corresponding sides because they are in the same relative location. Now, to find out if the triangles are similar, we have to determine if the corresponding sides are proportional. So what we're going to do is we're just going to check all of the pairs of corresponding sides to see whether or not they are proportional. So I'm going to compare the blue sides to the red sides and see if they're proportional. There's 4 different ways we can see if these form a proportion. I'm going to use cross products. 3 times 15 is 45. 5 times 9 is 45. So okay, the blue sides and the red sides are proportional, but we have to check all of the sides. So we check the blue to the red. Let's check the blue with the green. 9 over 3 and 12 over 4. Again, I'm going to check the cross products. 3 times 12 is 36. 4 times 9 is 36. All right. Those pairs of sides are proportional. One more set to check. Need to check the red with the green. 15 over 5 and 12 over 4. If I check these, I'm going to get 60, and 4 times 15 is also 60. So all of the sides are proportional. All of the corresponding sides are proportional. So yes, these are similar figures because the corresponding sides are proportional. Let's look at another. Here we have some rectangles. We're being asked if they are similar. Well, we're going to have to check the corresponding sides. 40 and 10. Now they're rectangles, so we know that the sides opposite are also 40 and 10. And the widths of these rectangles are 10 and 2.5. Put it in your calculator if you need to. Probably don't for this one. 10 times 10 is 100. 40 times 2.5, also 100. So again, we have yes, these two rectangles are similar because their corresponding sides are proportional. Let's do another. We have triangles again. Are they similar? I'm going to compare the green sides, the green corresponding sides with the red ones. I'm sorry, with the blue ones is what I wrote down. 4 times 10, 40. 5 times 8 is 40. Now I'll do the green with the red. 8 and 4, 12 and 8. Okay. 4 times 12 is 48, but 8 times 8 is 64. So these corresponding sides, these pairs, they are not proportional. So already we know that the triangles are not similar, because all the pairs of corresponding sides have to be proportional for the figures to be similar. I'm going to go ahead and double check with the blue and the red side. Even though we already know that they're not proportional, I'm going to make sure. Here we have 5 times 12 is 60, and 8 times 10 is 80. So here we've got another one where they're not the same. All the pairs of corresponding sides must be proportional for the figures to be similar. Okay, that's corresponding sides. Corresponding angles is a lot easier. If you look back at the notes from the very beginning of this video, it says figures are similar when corresponding angles are congruent. Congruent, I'll just write it down here. Congruent means equal. Congruent is the geometry word for equal. So if I look at these two triangles, they both have right angles. They both have right angles. The angle above the right angle is 40 in both of them, and the angles to the right of the right angle are both 50. Because that's all we know about these triangles, we don't know the side lengths. We do know the angle measurements, and yes, they're similar because the corresponding angles are congruent. And again, congruent just means equal. They're the same. Let's look at another one. Well, here are some pentagons. So are they similar? Looks like we have right angles on the bottoms of both of them. But then up here at the top, the red angle, we've got a 90 and a 135. And then the green angles are different. These are 135 and these are 112 and a half. So are they similar? No, they're not, because the corresponding angles are not congruent. They have to be the same. If they're not the same, then they're not congruent, which means the figures are not similar. Alright, are they similar? Oh, here we have two rectangles. Looks like we know stuff about the angles and the sides for this one. Well, goodness. Are all the angles congruent? Yes, they are. They're all 90 degrees, so we know that's true. But is the part about the sides true? Are the corresponding sides proportional? Well, let's check. We've got 12 and 12, and we've got 6 and 4. I think we already know. 12 divided by 12 is 1, and 6 divided by 4 is not 1. So no, they're not proportional, so the rectangles are not similar. You can check the cross products also if you want. But they're both rectangles, but they're not similar figures. This is a longer, skinny rectangle, and the rectangle on the left is wider. For figures to be similar, two things must be true. The corresponding sides must be proportional, and the corresponding angles must be congruent. Write down any questions that you have. We'll talk about them soon. See you then.